Okay, so as I said earlier, an else statement is matched to the last unmatched if. So no matter what the indentation implies, so you will at the end match your else to the last unmatched if. Okay, so that's an important property. You may have questions related to that. The switch statement, if you recall, it gives you an opportunity to select from multiple entries using the switch and case statements. So each case contains a value and a list of statements. Whatever you would like to execute, you can execute that. So if you recall the switch statement, the syntax had switch expression. So we had the expression. Based on this expression, we select either one of these cases. So I will select if the expression is equal to case value 1, I will execute this, value 2, value 3, and so on. So what was the last entry if I had none of them matched to my cases? The default was the last option which I had. If none of those map, I will choose the default option and execute whatever that requires. So if you remember, what do I use after each case statement mostly? Most of the time, what do I use after each case statement? I heard something. Break, right? So in order to break the case, you have to use a break after all these statements such that you can continue with the next statement after the switch statement. If you do not put a break, what happens? You continue with the next case until there's a break. So you go execute the statements in this case. If you don't have a break afterwards, what you will do is you will go with the statement list 2 and continue with this one until you see a break. This might be useful in certain cases, but most of the time what would you like to have is usually have a break after each case statement. So if you have, let's say, in which cases this without a break might be a reasonable thing to write. So where should I choose not to have a break? Default by default has a break at the end, so you don't need to write break. But other than that, I intentionally don't put a break after a case statement. Why would I do that? Exactly. So if you have the same thing that you want to apply for multiple cases. So let's say I have a certain switch, and then I have ch char, and I would like to have case A. I would like to do something, and then for case B and C, I will have a break after the statement. For case B and case C, let's say I would like to do the same thing. In that case, I will skip case B without any breaks, and then I will have my statement listed in my case C and have a break here. So that whenever I see case A, I will execute whatever it is, break it. However, if I see a B case, then what I do is I will skip this one and then continue with the C's and break it. So I will do the same thing on multiple cases as shown here without having the break. Okay, that's where it is mostly useful if you need to implement something like that. Any question? As I will come shortly, it should be an integral type. Integral type means it has an integer conversion that you can use, which in this case could be a character and any type of integer such as short, byte, int, and long. It cannot be double, it cannot be boolean, it cannot be floating point number. So it must be one of those types. Integral type meaning that, if you recall, every character has a corresponding integer representation, which is in Unicode 1 byte. And also the integer values, as we said before, int, short, long, byte. You can use those for switch statements. As again, a break statement is used as the last statement in each case a statement list. If it is not used, the flow of control will continue with the next case you have. So an example, you have switch option must be a character since you have a character here. A count plus plus and then break. If it is B count plus plus break. If it is C count plus plus and break. Obviously you can write this using if statements as well, but it gives a neater way to understand what is going on with each case in switch statements. Again, you can use ifs if you like to implement it that way. As we said earlier, the default case indicates if it doesn't match any of the cases, it is going to execute that default so that you may want to perform a certain task if it doesn't fit to any given cases you have at the top. So, as I just said, the expression of a switch statement must result in an integral type, meaning that an integer or a char, an integer could be a byte, short, int or long. So you have to have one of those as your expression. It cannot be a boolean, floating point or double number, and you cannot perform relational checks with a switch statement. So if you want to see whether something is greater than something and go into that case, that's not possible. Although it is possible somewhat in C, it is not available with, or C++, it's not available with Java. Grade report.java, let's go there. So if you look into the main, you have the grade and the category integer defined, and then you have a scanner to read from the user. So enter number grade between 0 and 100, so that next thing you read the entry from the user from the keyboard, scan next int, and I get the grade, I get the category it belongs to. What we mean by the category here is that a number between 0 to 10. So you have grade divided by 10, so whatever is entered basically divided by 10 as an integer value. And then that grade is, when you switch the category, you check for individual grades and then see what it belongs to. So as you can see, case 10, system out print line a perfect score, well done, break. If it is 9, you say well above average and so on. And then case 6, you say below average and then break. And the default case, as shown here, indicates that it is for all the other values less than 6, which is basically 5 and less, will be written for those scores. We will see not passing written there. So what I meant by the without break case is that if you would like to have a case where you have for both case 10 and 9, if you would like to print well above average excellent, then you can use this without a break. So if it is 10 or if it is 9, it is going to execute this line and then break afterwards. Okay? I'm not going to compile this. It's basically selecting one of the grades among the list. So comparing data, there are certain cases where we would like to be careful with comparisons. One is floating point value comparison. The reason is because floating points may differ even with really small values. 10 to the minus 9, 10 to the minus 8 might even be a small difference, so it is hard to get an equality between floating point numbers. Even with, if you change the order of calculations, associativity may not apply. For example, if you say A plus B plus C, the result generated by this might be different from A plus C plus B. Or even you can consider this example. If you consider this first, and then add the C on top of that, this might be different than adding these two first and adding A on top of that. The reason is because you have a limited representation in the computer with, let's say, 32 bits you are representing each floating point number, then your precision will be lost with these additions. So the result of A plus B plus C might not be same as A plus B plus C. So the associativity does not apply to floating point numbers, and that's why when comparing floating point numbers, you may want to put a tolerance to see if that tolerance is satisfied. You can say they are equal. Okay, so that's usually what is done. However, if you have a scientific application which is really considering small precision numbers, then in that case you must be more careful with this kind of comparisons. Comparing characters. So with the characters, we have, how do we compare the characters? Based on what do we compare them? Right, we compare them based on their Unicode representations, right? The ASCII character set, whatever they have, corresponding binary representations, we compare them based on those values. And if one value is bigger in terms of representation than the other one, we can do that kind of comparison. Most of the time, smaller a is less than smaller b, and so on. And then similarly, capital A is less than capital B, and the rest of the characters in the alphabet will be bigger than A if they are capital. We will see the order shortly. And then also comparing strings, because you have to be careful, since you cannot compare, these are objects, you cannot compare objects one to another unless they are referring to the same exact memory location. So you have to be careful with that. Also, same applies for the objects. These are actually meaning the same thing. So for strings, what do we use for comparison? Equals method call is used for comparison, right? Whether one string is equal to the other one, we do it by equals. Two floating point values are equal only if their underlying binary representations match exactly. So it is hard to get to match those two exactly. So you would like to, most of the time, have a close enough result if they are, if their difference is less than a certain threshold. So that's usually what is being done. If the absolute difference of two floating point f1 and f2 numbers is less than the tolerance, let's say 10 to the minus 6, then you say they're essentially equal. However, again, if you're running a scientific experiment which is so sensitive with this kind of comparisons, you have to be more careful, and they have different methodologies to do that. So comparing characters, the character plus is less than the character j because it comes before in the Unicode character set. So the binary or the number representation of plus is less than j, and that's why it is going to be coming before j, and it is going to be less than j if you do a comparison one-to-one between these characters. So you can compare characters based on their orders. So when you look into the orders, you can see that the characters from 0 to 9, the numbers are in Unicode values, you have 48 to 57. And then for A to Z, you have 65 to 90. And then for A to small z, you see that 97 to 122 as its binary or Unicode representation in computer. So what do you see when you look into these two numbers? What do you see as the difference? What's the difference? One thing that is identified by one of the students is that, as she said, the capital is does have a less number compared to the small letters. And another one is when you subtract 97 from 65, what do you get? This is intentionally selected. It is equal to 32, right? 32 is equal to, so when you subtract 65 from 97, you see that it is equal to 32, which is equal to 2 to the 5, right? The advantage of doing that is actually when you write this 32, 65 and 97, let's write 67 in binary. So how do I write 67? So I have 64, 32, right? And then I have 16, 8, 4, 2, and then 1. So this is 65, right? To represent 97, what do I need to do? I need to add 32, which is this bit, right? So this is 67, and then 65, sorry. And then you have 97, which is represented like 1, 1. So I have 64 plus 32, 96. And then I have 97. So what do you see? It's just one bit of change when you convert from lowercase to uppercase and vice versa. So if you just flip this 6th bit, then you can easily come up with the corresponding capital or lowercase letter in underlying representation. Okay, so this is done intentionally to make this conversion easier. Okay, so this way with just one flip you can get the uppercase or the lowercase accordingly. So as I said earlier, we use equals methods to compare the strings. So if name1 equals name2, it is going to do the internal comparison. If they're equal, it is going to write, print on the screen, same name. So if you want to write your own equals method for a string, how would you write it? If you want to implement this by yourself. So I ask you to write a equals method for a string. So it is going to take, it's going to return a Boolean value, right? Boolean equals and then string str. How am I going to implement it internally, if you think that? How can you compare the string with the current object that is passed? Come on, you just compare. If I have a string A and then another string B, what do? The basic implementation would be you start with the first characters, compare them. If they're same, continue with the next one until you see a difference, you continue, right? If you see a difference, you return false. Otherwise, you continue comparing them. If all of them are same, if these two strings are all same, you return true. You compare character by character. So you basically what you have is for int I equals 0, I is less than, let's say you first, obviously you need to first check whether this string and your string have the same length. Otherwise you will need to give an error beforehand, right? Because if they're different length, then that's obviously they're different. If they both have the same length, then you can compare one to one. If they have the same length, I assume that you do the comparison beforehand here. I'm not going into that. And you just compare their characters by I++. So I start with the first entry, go all the way to the length, and compare str char at, right? I. If this str char at I is not equal to, let's say my object is my str dot, right, char at I. If they're not equal, I will say, oh, I found a different character, so I'll just return false. Otherwise, if everything goes fine, I will just at the end return true, saying that all the characters matched, so they must be equal. Any question?
So that length is a method or a special function?
It's a method for string library, for string class. So you call it with no argument, so you can get the length of the string. Any question? So you can also use a compare to method, which is basically going to compare name1 to name2. If this is less than name2, it is going to return you a negative value. If they are equal, it will return you 0. If this is bigger, it will return you a positive value. So based on that value, you can decide which one comes first and which one comes after. Again, you can do the same exact thing with the method like this, compare to method. You can come up with your own compare to method by just comparing character by character until, you know, if one is less than the other one, you return a negative value and so on. So in this case, as you can see, name1 compared to name2 less than 0, meaning that name1 is smaller, which means it comes first. And then if they're equal to 0, same name, otherwise name2 comes first. What do we mean by comes first? What kind of order is this? It's lexicographic order, right? So it's lexicographic order that we are checking. and it is based on the character comparisons that we have seen before. So if you have a capital letter, recall that this was smaller case a, right? This was capital A. So if I have a capital letter, does it come first or after? So let's say I have a fridge and then greeting. Which one comes first? Greeting comes first because it has a capital letter that at the beginning which is less than the F. However, if you had the smaller g, it would have been vice versa. Any question? So great and fantastic, same example. Great comes before than fantastic because G has a lower Unicode representation when you compare with fantastic. Again, as you know, any dictionary knowledge you have, book comes before bookcase since it's shorter. Comparing objects, if you recall, we never use the equal operator in comparing objects unless you're referring to the same memory location. If you're referring to two different objects and you would like to compare their internal representations, what you would like to use is equals method. And if you define a new class, you would like to define your equals method for that specific object or for that specific class as well. So always be careful with not using the equal operator. And usually, you know, this is one of the common mistakes people make. Assuming that when you compare that, when you make that kind of comparison, you'll get a correct result. Although it's not going to give any errors, it's just going to compare. But at the end, your execution will not be executed correctly. So be careful with this kind of error. So the while statements, we're going to do a little review of the while loop. So if you recall, we have the while loop, do loop, for loop, and you can select among these loops whichever is suitable for your programming needs. Most of the time, if you have a certain condition that is going to be set based on a certain thing, you would like to use a while loop such that you do perform the same task over and over until a certain thing happens. What was the difference between while and do while? The main difference? They're exactly same actually. There's only one difference, which is while executed based on the condition, it could be 0 or more times. However, do while loop is executed at least once. So you definitely enter the body of the loop, but continuing on an additional time depends on the condition. So this one is 0 or more, this one is 1 or more. So for loop, as you know, you have the initial setup and then the condition, and you have the increment at the end. So this was the while's representation. We check the condition and execute the statement. Again, we can have block statements in our program as well. So logic for a while loop, it obviously returns you back to the top of the loop, check the condition, continue as long as it's true. If it is false, you just fall down from the next instruction or next statement that you would like to continue. So while count is less than or equal to 5, so you initialize it to 1, and then you continually check for the count and then increment count by 1 and see what the last value, and then according to that print it on the screen. So how many times it is going to execute this loop? So it's going to execute for 1, and then 2, 3, 4, and 5. When it's 5, it's going to also execute. Whenever it becomes 6, it will exit the loop and continue from the next statement. So when you look into this average.java, okay. So this example, as you can see, we have the main method. We have the main method, and then you have a sum equalized to 0, so it's equal to 0, and then we have count equal to 0. Average is also Average is also set to initially no values, but as we go we will initialize and add that up. So enter an integer 0 to quit. So it asks you to enter an integer and then 0 to quit until it sees 0, it will continue. So this is called a sentinel. Sentinel means the last entry of a sequence. Whenever the user enters that, it will finish execution. So let's run this to just see. Again, I need to compile. So when you look into this, enter an integer 0 to quit. So I will just enter 5, 6, 8, 9, 12. As you can see, what it keeps track of here, it tells me the sum so far is 5, and then adds the new entered value 11, 19, 28, 40. So it accumulates the number as I enter new values, right? So until I add more values, it's going to continue. So if I want to exit this thing, as you can imagine, this is a loop, right? I'm in a loop. Where do I exit the loop? So when the user enters 0, I must exit the loop. So 0 to quit means that I will just hit 0 here, and then the average is 16. So it just summed up all those values. The last value 96 divided by how many entries I had there. So if you think of this, how is this written when you consider the loop? There must be first a sum, right, that keeps track of the current sum, and then there must be another variable. What is the other variable that I need to get an average? Count how many entries I have received so far. So I will keep track of it and increment it by 1 every time the user enters a non-zero value. So I increment the counter, and then at the end of the loop I must have a statement that tells sum divided by count to get the average. So when you look at the code, you see that, so we have the scanner, and then we read the next integer before we go into the loop, and then I check whether it is equal to 0 or not. If it is 0, I will just not exit the loop and leave it immediately. However, in this case, since it is not entered 0 as our case, it will go into here, increment the count by 1, and then add value to my sum. Remember, this was equal to sum equals sum plus value. So I add value to the sum, and that's going to be the last result of it. And every time I get the sum, I print it on the screen and ask the user to enter a new value and read it and check this new value and see it is equal to 0 or not. If you converted, if you think of this in another way, what would you pick to write? How would you write it in another way? Do while, right? It is more suitable for this because the first entry you would like to see, you want to first read the value, and then based on value you would like to decide accordingly. So if I was to modify it to a do while, how would I do that? So I will just cut this while, right? I will have a do here, and then I will have the condition here, right? Is it going to need anything else? I'll need a semicolon, right? What else? What else do I need? I will need to cut this and scan the value first, and then sum the value until the value is not equal to 0. Is there a problem here? If the user enters the first time as 0, what's going to happen? If the user enters a 0 at the beginning, our sum will be equal to 0, and then we will exit afterwards. So it is going to, in a sense, have a 0 average at the end. Which is the problem? No, right? It is normally what would happen with the previous case as well, because if the sum is equal to 0, if count is equal to 0, it says no values entered. However, in our case, what we would need to check is for the sum value. If it is 0, we will write something else and do the same exact thing. So it depends on your implementation. As you can see, when you look into the else part, it gets the average for the result, and then you have a double sum and divided by the value by the count. So it's casting it to the double. This was what the parentheses would indicate, right? And then, as you can see, we have a decimal format FMT, which is defined here. So it is going to have an optional 3 digits after the decimal point. So if you have more decimal points, if you have more digits after this, you don't want to include those. However, if you would go until at most 3 more digits after the decimal point. And it's going to FMT.format average. So it's going to format your average into that format and then paste it to the end of the string. Again, if you have a string and you concatenate something onto that, it is going to be, as if it's a double integer, it is going to be converted to the string and concatenate, right? So you have the value printed as in that format given there. Any question? So this is actually one of the most common places where it is used. You use a loop to test for an input validation. So you make the program more robust, meaning that you won't allow the user to enter a value that is not in the boundaries. As you said before, you can see this win percentage application. Let's see that. So if you look into here, let's see the code. So I have constant number of games 12, and then I have an integer set to 1, initially no values set. Double ratio, I have a scanner again to read the keyboard input. I enter the number of games 1, 0 to 12, and then I read the next integer from the user, from the keyboard. And while 1 is less than 0 or 1 is greater than number of games, I will say invalid input, please re-enter and read the next input value. This will iterate until the user enters a correct value that is in the range of 1 to 12. So if it is less than 0 or greater than 12, it is going to give me, ask me the same thing over and over until this condition is not true. Okay? So you can use this kind of implementation for any menu entry or user input kind of things. And once it is entered correctly, it is going to just get the ratio 1 divided by number of games and then format it according to the current format, and then we'll print it on the screen. Any question? Infinite loops. How does an infinite loop happen? If the condition always evaluates to true, then in that case you will have an infinite loop. You will never be able to exit the loop. You can only exit by Control-C, where you just halt the whole execution and then stop executing the application and return back to the program. So it's easy to write infinite loops actually. I don't know if you have faced while you were writing your CS101 programs, but it's usually easy. So if you look into this while loop, it seems like a pretty nice loop which is going to just execute fine. However, when you look into the internal logic, it starts with count equals 1, and then it checks whether count is less than 25. However, the problem here is, what's the problem? Every time it is decremented by 1, which means it's going to start with 1 and then go into negatives, 0, -1, -2, -3. It will never be greater than 25, so this will always be true. The count will always be a negative value from that point on, and then you will go into an infinite loop. So you will only exit the loop by Control-C. Any question? So you have to, you have to be careful with your conditions. Nested loops. So nested loops, you have a loop inside another loop. That's what we call a nested loop. And this is also useful, for example, in any image rastering or computer vision application. You have pixels that go on the x and y dimensions. So you must have 2 dimensions at least to iterate on these pixels. So you have to have 2 for loops nested one another one, or a while loop. So nested loops are widely used. Let's see this palindrome tester Java example. Okay, let's see where this is. So what's a palindrome? Ey edip Adana'da pideye, right? So it's a palindrome. Or there was another one. Anybody remembers? I forgot. Madame, yeah. I forgot. There was one thing with madam, but I forgot the English one. So basically what you probably want to do is, for a palindrome check, you would like to see the string and then compare characters from the beginning and from the end and come towards the middle to see whether they are equal. Until you see a mismatch, you will say that they are equal. If you see a mismatch, you will say it is going to, they don't match. So in that case, you'll say that they're not palindrome, or it's not palindrome. And if you look into this string str, and then another is equal to y. So these are 2 strings. This one is not initialized, but this one is initialized. And then you have integer left and right. So we have a scanner that takes in again user input. And we have while another equals ignore case. So do you remember what equals ignore case was? So it doesn't care about the capital or lowercase, but what it cares is that it equal to capital Y or lowercase y. So if this string is equal to y, then it is going to continue. Unless you press something else, it is going to continue doing the same thing. And it prints enter a potential palindrome. So the user enters a palindrome and then you read it. String next line. So I read the string, and then left starts from 0, so the leftmost character, and then I have right set to string length -1. Why do I use string length -1? So this is the first entry, which is 0, and then the last one is length -1. So this is the last entry I have, length -1. So I go all the way to the end, while this str char at left is equal to str char at right, and left, and also, as you can see, left is less than right. So meaning that, so I'm going in both directions. My left is pointing to 0 initially, and then my right is pointing to this one. So I will increment left by 1 and right will be decremented by 1. So this one will go towards right and this one will go towards left. So they are going to at some point meet. So this is what it is checking. Whether left is less than right, I can continue checking. If they are equal or right is greater, then I must stop because I already checked all the entries so far. Right? That's what that means. So every time I check whether the char at left position is equal to char at right position. If they are equal, and also if my left is less than right, I continue check and increment my left by 1 and decrement my right by 1. And if that is true, then what's going to happen? It is going to check. The next condition is here. If left is less than right, that means I have stopped before I checked everything. So it stopped somewhere here. So my left came here and then right came here, but they couldn't meet. Why they couldn't meet? Because these two things were not equal, so that I couldn't continue. I found a different mismatch, and in that case I stopped execution, which means they're not palindrome. However, if left is not less than right, meaning that left and right pointing to the same place, then in that case they met and they finished all the traversal from left and to the right, so they must be equal since they came all that far, and in that case that string is a palindrome, will be printed on the screen. Okay? So you may wonder, where's the nested loop here? Where's the nested loop? Where's the nested loop? There it is, the nested loop. So you have first one checks for the next question. So you enter another text to see whether it's a palindrome. That's the outermost loop that is checking that. And then the innermost loop checks whether the string that you just entered is a palindrome or not. Right? Any question? So when you look into this example, how many times will I execute this nested loop? Or how many times I will have here printed on the screen? How many times? It's simple. I start with 1 and then I go all the way to execute the internal part of this loop. I will start with 1, I will do 2, 3, and then all the way. When I reach 10, when my count 1 is incremented by 1, I reach 10, I will do it again because it's equal to 10. So I will do for the 10 as well. So 10 times the outermost loop will iterate. And then for the innermost loop, I will start again with 1, and then I will go up to 20. So I will have in each of these iterations, I will have 1, 2, all the way to 20. So I will have 10 times 20, 200. So I will have 200 here is printed on the screen with this example. Any question? So obviously if you didn't have the equal sign and equal sign there, it would be 9 times 19, right? So it will just be reduced by 1 for each index variable. So I will finish this with the iterators. So an iterator is an object that allows you to process a collection of items one at a time. So you can iterate over the objects and operate on them one at a time. So you can step through each item and process it as needed. The next method returns the next item. So if you recall, we were using iterators in for loops. What was the term that we were using for iterators in the loop? We had a different kind of loop, like similar to for each, right? We had the for each loop, which has a variable that iterates over the variable. I will show that to you in the next lecture, so let's stop here. I'll see you tomorrow.